What if I told you that the world we see is just a tiny slice of reality? Imagine a vast cosmic cake, and our three-dimensional world is just a single thin layer within it. This mind-boggling concept is the essence of higher dimensions. The idea that our universe extends far beyond what our eyes can perceive. Our senses are finely tuned to navigate a world of length, width, and height. We effortlessly grasp the concepts of up and down, left and right, forward and backward. But what if there are dimensions beyond these familiar directions? What if our universe is a tapestry woven with threads we can't even begin to see? The quest to understand these hidden dimensions has captivated physicists and mathematicians for centuries. It's a journey that takes us to the very edge of human comprehension, forcing us to confront the limitations of our perception and the profound mysteries that lie at the heart of the cosmos. The human mind craves understanding, seeking patterns and explanations for the world around us. For centuries we've explored the furthest reaches of our planet, peered deep into the cosmos, and probed the building blocks of matter. Yet the concept of higher dimensions remains one of the most tantalizing and elusive mysteries. Why do these extra dimensions hold such fascination? Perhaps it's the inherent human desire to push beyond boundaries to explore the unknown. Or maybe it's the realization that our everyday experience, as confined as it is to three dimensions, might be just a tiny fragment of a much grander reality. Whatever the reason, the pursuit of higher dimensions is more than just a theoretical exercise. It has the potential to revolutionize our understanding of the universe and our place within it. It could unlock new frontiers in physics, redefine our concept of reality, and perhaps even lead us to technologies beyond our wildest dreams. To grasp the mind-bending nature of higher dimensions, let's first revisit the familiar territory of our own three-dimensional world. Imagine a simple line. This line exists in one dimension. It has length but no width or height. Now, add another line perpendicular to the first, and you create a plane. This plane represents two dimensions. It has length and width. Finally, imagine extending that plane vertically, and you have a three-dimensional space, our familiar world of length, width, and height. But the story doesn't end there. Physicists believe that time itself constitutes a fourth dimension. We experience time as a linear progression from past to present to future. But imagine a being that could perceive all moments in time simultaneously, just as we perceive the three spatial dimensions. This is the realm of four dimensions, where space and time become intertwined, yet, even this is just the tip of the iceberg. String theory, a leading contender for a theory of everything, suggests that our universe might have as many as 10 or even 11 dimensions. String theory, a pillar of modern theoretical physics, proposes a radical idea that the fundamental building blocks of the universe are not point-like particles, but rather tiny vibrating strings. These strings, far smaller than anything we can currently observe, exist in a multidimensional landscape. Just as a guitar string can vibrate at different frequencies to produce different musical notes, these cosmic strings vibrate in different dimensions, giving rise to the particles and forces we observe in nature. But if these extra dimensions exist, why can't we see them? Why are we seemingly trapped in our three-dimensional world? String theory suggests that these higher dimensions are curled up or compactified at incredibly small scales, far beyond the reach of our most powerful instruments. Imagine a garden hose viewed from a distance. It appears as a one-dimensional line. But up close you see its true two-dimensional surface. Similarly, our universe's extra dimensions might be hidden from view, curled up at the Planck scale, which is billions of times smaller than an atom. While we can't directly observe these higher dimensions yet, their existence could explain some of the most profound mysteries of our universe, from the behavior of subatomic particles to the very nature of gravity. Section 5. Flatland, a glimpse beyond. To truly grasp the mind-bending concept of higher dimensions, let's take a page from Edwin Abbott's classic novella, Flatland. Imagine a two-dimensional world inhabited by squares, circles, and triangles, all confined to the surface of a flat plane. These beings can move forward and backward, left and right, but they have no concept of up or down. Now, imagine a three-dimensional sphere passing through Flatland. To the inhabitants, the sphere would appear as a series of two-dimensional circles, first appearing as a point, then growing larger, then shrinking again until it vanishes. The Flatlanders, limited by their two-dimensional perception, would have no way of comprehending the true nature of the sphere. Similarly, we might be like the Flatlanders, unable to perceive higher dimensions that intersect our own. A four-dimensional being passing through our world might appear as a series of three-dimensional objects, defying our understanding of physics and causality. Section 6. Visions of higher realms. If we could somehow develop the ability to see in higher dimensions, our perception of the universe would be utterly transformed. A four-dimensional being, for example, could perceive all points within our three-dimensional world simultaneously, just as we can see all points on a two-dimensional sheet of paper. They could see inside your body, through walls, and even into the past and future, as all of these points would be interconnected within their four-dimensional perspective. As we climb the dimensional ladder, the possibilities become even more mind-boggling. A five-dimensional being might be able to perceive all possible timelines for our universe, seeing all the different paths history could have taken. And a six-dimensional being might have access to an infinite number of universes, each with its own unique set of physical laws and constants. While these ideas might seem like pure science fiction, they emerge from serious scientific theories and mathematical models. They highlight the vast and uncharted territory that lies beyond our everyday perception, urging us to expand our minds and consider the truly awe-inspiring possibilities of the cosmos. Section 7. The Science of Extra Dimensions. The quest to understand higher dimensions is not merely a philosophical exercise, it's a scientific pursuit grounded in rigorous mathematics and cutting-edge physics. String theory, with its elegant framework of vibrating strings and extra dimensions, offers a compelling framework for unifying the forces of nature and explaining the behavior of the universe at its most fundamental level. Experimental physicists are also on the hunt for evidence of extra dimensions. At the Large Hadron Collider, scientists smash subatomic particles together at incredible speeds, hoping to create fleeting glimpses of particles or interactions that hint at the existence of hidden dimensions. These experiments could reveal subtle deviations from the predictions of standard physics, pointing towards the existence of new particles, forces, or even dimensions. Furthermore, the strange and counterintuitive world of quantum mechanics might also hold clues to the nature of higher dimensions. Some interpretations of quantum mechanics suggest that particles can exist in multiple states or locations simultaneously, a phenomenon known as superposition. This bizarre behavior might be a consequence of particles interacting with higher dimensions that we can't directly observe. Section 8. Implications of a multidimensional reality. The implications of seeing in higher dimensions would be profound, impacting not only our understanding of the universe but also our technology, philosophy, and even our very sense of self. Imagine the possibilities if we could harness the power of extra dimensions. We might develop new forms of communication that transcend the limitations of speed and distance, tap into unimaginable sources of energy, or even manipulate the fabric of space-time itself. Philosophically, the confirmation of higher dimensions would revolutionize our understanding of reality. It would mean that our universe is far more complex and interconnected than we ever imagined, challenging our notions of causality, free will, and the nature of consciousness. It would also raise profound questions about the possibility of other intelligent beings inhabiting these hidden dimensions, and the potential for interacting with them. The discovery of higher dimensions would be a paradigm shift for humanity, akin to Copernicus's realization that Earth is not the center of the universe or Darwin's theory of evolution. It would reshape our understanding of our place in the cosmos and open up new avenues of exploration for generations to come. Section 9. A universe, yet unknown. As we stand on the precipice of this new frontier of scientific exploration, we are filled with a sense of both excitement and humility. The universe has a knack for surprising us, revealing wonders that dwarf our wildest imaginings. The quest to understand higher dimensions is a testament to the boundless curiosity of the human spirit and our relentless pursuit of knowledge. While the challenges of both biological and technological limitations remain, the potential rewards are too great to ignore. The journey to unlock the secrets of higher dimensions will require ingenuity, collaboration, and a willingness to embrace the unknown. But if successful, it could usher in a new era of scientific understanding, technological advancement, and philosophical enlightenment. The universe is vast, mysterious, and full of surprises. As we continue to explore its hidden depths, we must remain open to the possibility that our reality is but a tiny fraction of a much grander, multidimensional tapestry. The journey to understand these higher realms has just begun, and the discoveries that await us promise to be nothing short of revolutionary.